All right, we're back. We are on page 2 of Calc AB Note 7, which is related rates. We're going to take a look at one that actually involves some geometric setup because that when I think of related rates, I really think of that. Like it's going to be a lot of cones, a lot of triangles. Honestly, things are constantly falling into cones and forming cones, like sand falls and forms a cone, things like that. What else? Like spheres and they expand or contract. It's just a lot of things. So let's see if we can do this. So a right triangle has legs x and y and a hypotenuse z. So maybe we should draw that. So hypotenuse will be z. And then somehow it just like knows that I want to make a triangle and like kind of fixes it for me, I think. I don't really know. So we'll say that this is z. This is x because it's horizontal, and this is y because it's vertical. Like that's the way you should set those up. All right, so if x is increasing at a rate of 3 units per second, so x is increasing at a rate of 3, so getting bigger. So over time, x will be a bigger thing, which means its rate of change is positive, right? If it starts out at 1, then 1 second later it will be 4. It got bigger. So dx dt is positive 3 units per second. I don't usually write the units when I write down all my givens. It's probably a bad idea. You should probably do that. So y is decreasing at a rate of 2 units per second. So if y is currently 5, 1 second later, it will be 2 units shorter. It'll be 3. So it's getting smaller. So dy dt is negative. And this is like a key thing. You have to go through the problem and you got to like isolate the given information. I like to write it down, take away the context. Like, so I'm going to try to turn it into an algebra problem that I can just like do. Find the rate of change of z when x is going to be 5. So x will be 5, and y is going to be 12. Now, here's the thing. X and y change as time changes. So I do not want to substitute those values until after I have taken a derivative. You always wait to substitute values that can change until after you take the derivative. Because if you substitute too soon, then something that's a variable becomes a constant, and the derivative of a constant is 0. And suddenly you like lost all this notion of the ability to change. So watch out for that. Never do that. Never sub. Here, let's put it down. So never sub for things that change until after you take derivatives. So this is a really big thing. I really want to abbreviate that. I really wanted to abbreviate that. After, I'm going to highlight that. Never substitute something that can change until after you have taken derivatives. So what I want to do is I want to come up with a formula that relates these things, right? So we're looking for dz dt. So find dz dt. And now what relates these things? Well, this is a right triangle. I don't usually label the right angle, but I probably should. So I know that x squared plus y squared is equal to z squared. Now, what are we going to do? Everything changes with respect to time. So let's take the derivative of this thing with respect to time. So d dt of x squared plus y squared is d dt of z squared. Okay, so now we take the derivative. I'll do that over here. Remember, x is a function of t, y is a function of t, z is a function of t. Everything's a function of t. So the derivative of x squared is going to be 2x, but by the chain rule, dx dt. The derivative of y squared is going to be 2y, but by the chain rule, dy dt. So 2y dy dt. And then same for z, 2z. This is why you cross your z's. It's when you get all these 2's and z's and whatever. So we have all this. Now, what are we trying to find? We're trying to find dz dt. And we know an awful lot of things that we can already sub in for. So we know dx dt is going to be 3. We know x is going to be 5. We know, what else do we know? We know, I was more like saying to myself, like, what other colors do we have? Y is going to be 12, so that's good. And then I need one more color. This might be crazy. No, it's not that bad. We know that dy dt is negative 12. So we're going to make all those substitutions. What we don't currently know is what z is, but since we do know this, x squared plus y squared equals z squared, so I do know that, where shall I put this? I'm gonna put it over here. What is it? 5 squared plus 12 squared. 5 squared plus 12 squared equals z squared. So z is 13. That's 5, 12, 13. Calculus problems love to use Pythagorean triples. Make sure you know your triples. 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. Those are the most common ones. Anything beyond that, 20, 21, 29 is my favorite triple. Doesn't really come up in related rates all that often. But I now know that I can substitute this for z. So let's make all of our substitutions, get an answer, and see what we get. So I'm going to divide everything by 2 because I can. So like, let's just say those are gone. We're going to have 5 times 3 plus 12 times negative 2 is equal to 13 dz dt. So dz dt is going to be equal to 15 minus 24 is negative 9. Negative 9 over 13. What are the units? The units are, bizarrely, units per second. So linear measures are units per second in this. So z is a linear measure. So we will say units per second. And I think that's a good answer. So I'm going to highlight that in, I don't know, this color, which maybe I already used. Hard to say. All right. So that's a very geometric problem. And so they just take a little while, right? So you find the givens, you draw your picture, you take a derivative with respect to time, and you're good. So let's see the next problem. Really similar problem, it looks like. So a 29-foot ladder. Now let's think about this. Do ladders change length? They shouldn't, probably. Like this 29-foot ladder should probably always be 29. This is my favorite triple. There's a 29 to 21. Look at that. I must have definitely written this problem. So a 29-foot ladder, ladders don't change length. So I don't need a variable for that. It's not going to change. Therefore, I can just plug in right away. Leans against a vertical wall. Let's draw that. Well, let's roughly draw that. So this, do it, and then, oh boy. Okay, so our ladder is 29 feet. So I'm just going to label it as 29 because it can never change. The rate of change of the ladder is 0. So we can actually plug in 29 without a problem. The foot of the ladder is moving away. So I'm going to say this is x, and this is the foot. That's the foot of the ladder. The foot of the ladder is moving away from the wall at a rate of 5 feet per second. So what does that mean? If at t equals 0, you're 2 feet from the wall, then at t equals 1, you will be 5 feet. You got longer, right? So this is telling us dx dt is positive 5. Why is it positive? Because it's getting longer over time. You need a positive rate for that to happen. Find the velocity of the top of the ladder. So what are we looking for? We're trying to find, we need a variable. I'm going to call it y. Find dy dt. That's our objective, right? The velocity of the top of the ladder. When the foot of the ladder is 21 feet from the wall. So x is going to be 21 only at the time we're interested in, right? X can be anything between 0 and I guess kind of 29. That's sort of like the limit of x because the ladder is 29. So like when it gets basically horizontal, then the foot will be like 29 feet away. All right, so what are we doing? I need a relationship. So I don't have a lot of givens here. I have far fewer than last time, which must mean something. What relationship? So right triangle, you're going to use this relationship all the time. Pythagorean identity. Pythagorean theorem. Pythagorean identity? What is that? It's probably the same thing, but you know, it made sense when I said it. You could hear it in my voice, though, that I was like, I don't know if I want to say it. 29 squared. Doesn't really matter what it is because we're going to take the derivative anyway. 29 never changes, right? So there's an alternative world in which you said that the hypotenuse was z. But then since dz dt is 0, you might as well have used a constant to begin with. That's what will happen when you use too many variables. You'll find a lot of the variables just have a 0 rate of change, which means they were actually constants to begin with. So let's see. Derivative with respect to t. I'm just going to skip that step and just go to 2x. X is a function of t, so dx. So it's better. All right, let's do the good job. d dt x squared plus y squared should be d dt. I really, really like skipping this step. All right, derivative of x squared, 2x, but x is a function of t, so chain rule gives me a dx dt, plus the derivative of y squared, same deal, 2y, and then a dy dt. Derivative of a constant is 0, so we just zero it out. If you had accidentally used a variable, you would have gotten 2z dz dt, but then dz dt would just be 0. So that would zero out anyway. So what do we know? We know, so we're missing y, right? We know right now we can substitute dx dt. We can substitute x for x. We are looking for dy dt, so we need to find something that we can substitute for y, but we have this relationship, right? So this is our relationship, so let's use it. So also, we just know that it's a 20, 21, 29 triangle. I definitely recommend, like, you got to know those triples because it's going to speed you up. So, I mean, we're faced with 21 squared plus y squared equals 29 squared, but I just know that y is going to be 20. So 20, 21, 29. So this will be able to substitute for y. Okay, and we have everything we need. So let's do it. I'm going to say that, again, I'm going to divide out the 2's. The 2's that, so in the Pythagorean theorem, obviously they're super important. In the derivative with respect to time of the Pythagorean theorem, everything gets a 2, so you might as well not have a 2. You just divide it out. So here we go. So 21 dx dt is positive 5 plus 20 is y. dy dt is what we're solving for, and this is 0. So I'm getting dy dt is, so what is this? A really good strategy, don't simplify until you need to. So I'm going to say 21 times 5 over 20. Why is that advantageous? 5 and 20 cancel. So, and this happens like a lot. So dy dt, I'm going to say, is negative 21 over 4. What are the units? So if you look at the problem, you can see feet per second. So y is also a linear measure, so it'll also be in feet per second. Feet per second. And this is our answer. So let's think, does our answer make, I'm looking for like a color I didn't use so I can highlight it. Does a negative value make sense? Well, if you picture a ladder, I don't know, climb a ladder and let it slide down a wall and see if it makes sense. To me, it makes a lot of sense because you start up high and then you get closer to the ground, right? So the length of your distance to the ground is decreasing, so the rate of change should be negative. So I think that makes a lot of sense. Should I do one more problem or should I call it quits? I'm gonna call it quits because the last time I did this, I was like, yeah, I'll just do one more, and it like took forever. So I'm gonna stop this here. I'm gonna come back in the next video, finish this page, maybe move on. Hard to say. We'll see. Watch the video. So see you there.